Hello everyone, I'm Golden Ashley. I'm here to present sensor node hardware components in the course of ad hoc and wireless sensor networks. So on completion of this video, students will be able to explain what are the hardware components and wireless sensor node. First of all, we are going to say about the sensor node architecture. The figure shows the sensor node architecture. So actually the basic components of a sensor nodes are a sensing unit, a processing unit, a communication unit and the power supply unit. So first the sensing unit. Sensors are used to measure the physical quantities like temperature, pressure, etc. from their environment. They are hardware devices. Each sensor node is used to produce a quantifiable response to a change in temperature or pressure of the environment. So sensors produce analog signals and analog to digital converters is used to convert the analog signal into digital signals. So the digitized signal can be sent to controller for further processing. So some sensors may contain the required electronic components to convert the raw signals into readings. So in general, sensor nodes are small in size and consume energy during operation. Then the second one is processing unit. So the microcontroller placed in the sensor is used to perform specific task, processes data and controls the operation of other component in the sensor node. So usage of memory in sensor node is purely application dependent. So external memory is used to store the collected information. Usually flash memories are used in sensor nodes due to their low cost and high storage capacity. Then the third one is communication unit. So sensor nodes or transceivers. Actually, sensor nodes use transceivers to communicate with other nodes. So the wireless communication media used in sensor network are radio frequency, optical communication, and infrared. Then fourth one is power supply unit. Sensor node consumes powers for sensing, data gathering, communicating, and data processing. So energy required for the data communication is more when compared with other process. So changing the battery sensor node can be mostly costly and inconvenient. So it is very important to ensure that the sensor node has adequate energy for performing operations continuously. Then the next one is hardware component of a sensor node. So four basic hardware subsystems of the sensor nodes are follows. What are that? Computing subsystem, power supply subsystem, communication subsystem, and sensing subsystem. First one is computing subsystems. So each sensor node consists of a microprocessor to control the sensor. So microprocessor until of every sensor node is responsible for executing and managing communication protocols. So this subsystem is also responsible for data processing and manipulation, error correction and encryption, digital modulation and demodulation. The second one is energy or power supply subsystem. So the lifetime of the sensor node depends upon the battery life. So batteries placed in each sensor can have only limited power. Since sensor nodes receive power from batteries, limited amount of power can be used for processing. So the amount of power being used by the sensor can be monitored by power supply subsystems. Depending upon the operating environment of sensor node, power can be turned on or off. So the battery used in sensor node has to be charged from the suitable energy source and hence make the sensor node to operate for pre-long period. Okay, then communication subsystems. In the third part is the communication subsystems. Short range radios are used to enable communication between sensor node and with other wired units. So each sensor node can be in any one of the following node. So transient or transient, receive, idle or sleep. So transmission and reception mode require high energy consumptions. In order to save energy, the mode of the sensor node can be changed to sleep mode when the sensor is in idle state. Then the last one is sensing subsystems. So the sensing subsystems is responsible for sensing the environment and exchanging information with each other sensor nodes. So different sensors are used to sense the physical conditions of the environment. Then software subsystems of a sensor node. Actually, it have following nodes are operating system microcode. Then second one is sensor drivers. Third one is communication processor. Then fourth one is communication driver. Fifth one is data processing mini apps. So first one is operating systems. This operating system microcode is used by high level modules of node resident software. So this microcode protects the software from the machine level functionality. So tiny OS is written in SC which is an extension of C language. It provides the support for event driven component based programming. So the event can be generated from any component and enables to perform specific tasks. Then sensor drivers. So these drivers manage the key functions of receivers which are embedded in sensors. In general, sensors are plug-in types. So depending upon and the operating environment of sensor nodes, the configurations and setting of application must be installed into the sensor. So sensor drivers are mainly used to protect application software from other drivers. Then the third one is communication processes. The various operations like routing the packet, buffering, forwarding packets, contention mechanisms using MAC protocol, encryption and error correction are performed by communication processes. Then fourth one is communication drivers. So these drivers are responsible for managing the following operations: transmission through radio channels, synchronization, encoding and decoding, error correction and checking, counting of bits, signal levels, and the modulation and demodulation. Then the last one is data processing mini apps. So this software actually subsystem is responsible for performing data processing at node level in a sensor network. Thank you. Thanks for listening.